So hello Year 8 and welcome to your 6th lesson on the topic Earth and the atmosphere. And today we're going to be looking at the carbon cycle and the greenhouse effect. A reminder that next week you will be having a mid-topic test on this topic and that does include the information from today. So hopefully this will be a slightly shorter lesson, giving you time to do some revision, and you will have homework this week, which is to revise for the test next week. Thank you to all those of you who have already contacted me to ask for a reminder about your Educake username and password. To the last few, if there are any of you out there, your test will be on Educake. We will expect you to do it, and I am going to be very frustrated if I get 50 people emailing me next week for their username and password. So, thinking back to last week, we were looking at the history of the atmosphere, and we saw that just like the atmospheres of Venus and Mars either side of us, our atmosphere used to be about 90% carbon dioxide, 90% of it. Now it's just 0.04% carbon dioxide. So where did all that carbon dioxide go? Pause the video. See if you can come up with 3 different ways. Okay, so this diagram will give some reminders for those of you who are struggling. One of the things that takes place is plants down here, they can photosynthesize, so photosynthesis. And this takes in carbon dioxide from the atmosphere, and plants use it to build chemicals in their bodies, carbon-based chemicals, and it gives out oxygen. And this is one of the main reasons why the amount of carbon dioxide went out, and it is the main reason why the amount of oxygen in the atmosphere increased. When those plants died, some of them got buried and turned into coal as a fossil fuel. Some of the carbon dioxide in the atmosphere dissolved into the ocean, and there's a lot of CO2 still held in the ocean today. And in the ocean, it got eaten by sea creatures and turned into shells for many sea creatures. When these died and fell to the bottom of the sea, they got compressed together and they formed a sedimentary rock called limestone. So a lot of the carbon, or the carbon from dioxide, the carbon from the carbon dioxide has got locked up as certain types of rocks. So rocks is another place that CO2 has gone. And of course some of these creatures from the sea got buried and turned into fossil fuels like oil. So you've got photosynthesis, you've got fossil fuels, you've got the oceans, you've got sedimentary rocks, and of course metamorphic rocks like marble, which come from those, and you've got locked up in plants and animals. So lots of carbon locked up all over the place. Is there anything putting carbon dioxide back into the atmosphere? So if plants, seeds, fossil fuels and rocks are all taking carbon dioxide out of the atmosphere, does this mean there will eventually be no CO2 left? Is it going to go down to 0? Well, no, for a couple of important reasons. Number one, photosynthesis here, which converts carbon dioxide and water using sunlight into glucose and oxygen. Well, there's loads and loads of plants and animals which are doing the exact opposite, which is taking the sugars that are formed, combining them with oxygen and respiring and putting carbon dioxide back into the atmosphere. Also, as I'm sure many of you are aware, whenever we burn a carbon-based fuel, so the fire triangle combustion that you looked at back in year 7, when we burn a hydrocarbon fuel with oxygen, we release water and carbon dioxide. So these two processes, respiration and carbon dioxide, we know putting carbon dioxide back into the atmosphere. And these ideas can be put together in something called the carbon cycle. And this is a picture of the carbon cycle. You may have encountered this in biology, but it's also relevant for this topic of Earth and the atmosphere, for a reason that you will see shortly when we move on to the greenhouse effect. This here, this C, represents carbon dioxide in the air. And of course, one of the ways that it's taken out of the air is photosynthesis. Plants using this carbon dioxide and turning it into sugars within the plant, so the carbon becomes locked up in the plant. From there's a few things that can happen. The plants at night time, they give out carbon dioxide, they respire just like animals do, using those sugars they've made, burning them with oxygen, producing carbon dioxide and water. And the plant can keep taking in carbon during the day and releasing carbon at night. Another thing that can happen to the carbon once it's locked up in the plant is that it can be eaten by an animal. This rabbit's called Peter, by the way. And what do we think might happen to Peter? I think Peter's going to die. His met a rather untimely end there. And poor Peter has pegged it. It's okay. He reached the end of his life. He was an old rabbit. What would happen to a dead rabbit? Well, bacteria would start to feed on Peter, and they would break down the carbon in his body, decay, and when they decay, they generate carbon dioxide and put the carbon back into the air, or it might be taken up by a plant, eaten by another rabbit. Let's call this one Lily. This time, Lily's perfectly well and healthy, breathes out the carbon back into the atmosphere, taken in by another plant. Now this plant happens to get buried and turned into fossil fuels, coal, oil and natural gas, until we burn them. And when we burn these things, when we burn these fossil fuels, we put the carbon back into the air as carbon dioxide. And you can begin to see how the carbon begins to flow through the cycle into the atmosphere and back out again. So let's see where the carbon goes. Into the plants, back out. It's fossil fuels, burnt. Into the plants. Fossil fuels, burnt again, into the plants. Now it's been eaten by an animal. Now the animal's died, it's decayed. I can't keep up. But you can just begin to see how the carbon spends its time flowing through the cycle back into the air as carbon dioxide, then into more complex molecules in the plants and the animals, sometimes getting locked up down here as fossil fuels for millions and millions of years, sometimes actually going straight in and out of the plants as it did there, maybe in only a day, but constantly cycling into the air and back out again. And what I'd like you to do is make your own version of this diagram. Make sure you've got all of the animals on. Make sure you know what respiration is, photosynthesis. Make sure you've got feeding. Make sure you've got excretion, decay, fossilization and combustion. It's worth saying that the amount of carbon dioxide in the air is extremely important. Even small changes in the amount of carbon dioxide are going to have a big impact on our planet. And the reason for that is due to something called the greenhouse effect. Now, don't confuse the greenhouse effect with global warming. They are different. They are linked, but they're not the same. So the greenhouse effect is not global warming. We'll be looking at global warming after the half term, but the greenhouse effect is not global warming. And the greenhouse effect comes due to the atmosphere of the Earth. So you know that the atmosphere is a thin layer of gases. This is not to scale. The atmosphere is only very thin around the Earth, as we saw in our very first lesson. Certain gases in the atmosphere trap the heat given off from the Earth. This trapped heat is reflected back to the surface and warms the Earth. We'll look at this in more detail in a second. Don't worry if that doesn't make sense right now. But the reason it's called a greenhouse effect is because light coming into the Earth that gets trapped as heat, it's just the same idea as sunlight coming into a greenhouse, and then when the light tries to leave as heat, or the energy tries to leave as heat, it's bounced back and kept in the greenhouse, and that's why it's called the greenhouse effect. And as it says there, without the atmosphere and the greenhouse effect, Earth would be too cold for life to exist. In fact, we owe our very existence to the greenhouse effect. It's purely natural, okay? So don't get thinking the greenhouse effect is something non-natural, something man-made. The greenhouse effect is perfectly natural. And other planets have greenhouse effects. So we're going to have a quick look at a video to explain this.
When the sun shines on the Earth, some of it is actually reflected back to space. Again, more of it if it's on an ice-covered part of the Earth or where there's lots of clouds. And some of it is then absorbed by the Earth. And when it absorbs solar energy in the visible spectrum, what happens is the Earth heats up in response because it's absorbing energy. And when objects heat up, they emit their own radiation, but in a longer wavelength. And so that radiation then heads back towards space. If the Earth had no atmosphere, it would be about 30 degrees colder. So we would actually have a frozen planet. We are habitable because of our atmosphere, and because our atmosphere has some greenhouse gases, in particular carbon dioxide and methane, the most important of which is actually water vapor. And so what happens is these greenhouse gases, they absorb some of the infrared radiation, the long-wave radiation, and re-radiate it both back to space and downward, but they act like a thermal blanket. So they essentially keep the Earth's surface warmer than it would be otherwise. And that's how the greenhouse effect works. And again, this isn't just a theory. We can actually say this is what causes Venus to be 460 degrees Celsius.
So this is a simplified version of that diagram. Energy from the sun is transferred. It goes straight through the atmosphere and it reaches the surface. When it reaches the surface, most of the energy is absorbed, causing an increase in temperature of the Earth. So the Earth warms up, just like you lying on a sunbed and absorbing the sun's rays, or a car getting very, very hot by absorbing the sun's rays so that when you touch the belt buckle, it burns you. And as the Earth warms up, you know from year 7 that this means as it warms up, it's going to start losing heat energy. It's going to start radiating. And so the warm Earth emits energy. Not light, so this is light energy, but now it's emitting heat. And heat is infrared radiation. And some of that does get straight through the atmosphere and back into space. But, and this is the crucial bit, this is the greenhouse effect. Some of that emitted energy is absorbed by carbon dioxide and other greenhouse gases and is sent back to Earth, where it keeps the Earth warmer. Not all the heat is lost to space. Some of it is trapped by this blanket. What are the important greenhouse gases? Well, there's a few, but the ones you need to know about are the famous one, carbon dioxide, and we'll look at that in great detail after May half term. Methane. Methane is also a very important greenhouse gas. The one that gets forgotten about is water. Water vapour, steam, is also an important greenhouse gas, although we can do far less about the amount of water because most of the water comes from seas and evaporation. So I said that the greenhouse effect wasn't just on planet Earth. Well, the planet Venus is further from the Sun than Mercury. So you've got the Sun, then you've got Mercury, then you've got Venus, then you've got Earth, then you've got Mars. So you would expect Mercury to be the hottest planet, but actually Venus is the hottest planet. And the reason for that is this carbon dioxide atmosphere that you learnt about last week. It's got an atmosphere that's almost entirely carbon dioxide, and this is a very, very extreme greenhouse effect, trapping lots of the heat there. And in fact, its surface can reach temperatures of almost 500 degrees centigrade, which is hot enough to melt lead. Because of the extremely high temperatures, because of the fact there's no liquid water, it would be impossible for life such as our own to exist. That's not to say that it isn't possible for a very different form of life to exist on that planet. So, what I would like you to do, if you haven't already made a copy of the diagrams of the carbon cycle and the greenhouse effect, there is a worksheet that you can copy or print out. It's up to you, but in your books you need a copy of the carbon cycle fully labelled, and you need a copy of the greenhouse effect. Then for the rest of this lesson and homework this week, about half an hour's homework, you should revise the material so far, because you're going to have a test next week on Educake, and this test will cover rocks and rock texture. That was lesson 1. So rocks and minerals, what's the difference? Grains, interlocking and rounded. Properties of rocks: hard, crumbly, are they porous, are they non-porous? Sedimentary rocks, weathering. What are the 3 different types of weathering? Can you give an example of each? What is erosion? How are sedimentary rocks formed? What are the properties of sedimentary rocks, and can you name some? Igneous rocks. What's the difference between an extrusive and an intrusive igneous rock? How are they formed? Some of the bits of a volcano, not in any great detail, but what's the difference between magma and lava? What are the properties of igneous rocks? And again, name some. Lesson 4, metamorphic rocks and the rock cycle. How are metamorphic rocks formed? The fact that they stay solid. They don't melt. If they melt, they become igneous rocks. They stay solid, but their properties change. And then the rock cycle. How do the rocks convert? History of the atmosphere. We did that last week. So how have the levels of oxygen, carbon dioxide and nitrogen changed in the atmosphere? Why have they changed? What are the reasons for those changes? And then from today, lesson 6, the carbon cycle and the greenhouse effect. What are the various processes that go on in the carbon cycle? Photosynthesis, respiration, fossilization, decomposition, feeding, and what is the greenhouse effect? What causes it, and what does it do? You won't see me next week because you'll just have your test to do. So the next time you hear from me will be after May half term, and I hope that you have a good week, that the test goes well next week, and then you have a nice week off. And I shall see you at the end of May. Goodbye.